Hey Brand Bombers, it's Miss Morel, and today we're going to be kicking off chapter number 5. So 5.1 talks about light and quantized energy. And so although that title might seem a little scary, it's really not meant to. So if you can do some basic algebra, you'll be just fine. And then also in this chapter, there are just some basic concepts that I think you'll all be able to have no problem at all mastering. All right, let's take a look. So our goals are to compare the wave and particle natures of light, define a quantum of energy, explain how it is related to an energy change of matter, and contrast continuous electromagnetic spectra and atomic emission spectra. Whoa, that might sound scary, but it's not going to be. All right, so radiation is our review vocabulary. We learned that in section 4.4, so that wasn't very long ago. So we'll have some new vocabulary. And the main idea is light is a form of electronic radiation. It has both wave and a particle. Okay, so it has wave and particle. So we'll be talking about that. There's a video if you take a look at the slideshow. I would love if you'd watch. It's just talking about different types of radiation in our homes, in our lives. So if you would recall that in Rutherford's model, the atom's mass is mostly concentrated in the nucleus. Remember that electrons are the only thing outside of it, and they weigh almost nothing. So the model doesn't really explain how the electrons were arranged around the nucleus, and it doesn't explain why negatively charged electrons, why aren't they pulled into the center where the nucleus is, where that positively charged protons live. All right, so in the early 1900s, scientists observed that certain elements emitted visible light when heated in a flame. That sounds exciting, huh? So the analysis of this is that the emitted light revealed that an element's chemical behavior is related to the arrangement of atoms. And so that's what we are going to be learning about in the chapter. In my mind, that's the biggest thing, is that when we look at where the atom's electrons are, that is what matters to us. So important to know that light, we will see it as both a wave and a particle in this chapter. All right, so visible light is part of the electromagnetic spectrum. So that's where we're talking about like Roy G. Biv, the rainbow and all the different colors in it, and a form of energy that exhibits wave-like behavior as it travels through space. It'd be awesome if you were taking notes, so write that down if you are. All right, all waves can be described by several characteristics. So wavelength, frequency, and amplitude. So those should be old news for you. So we can see wavelength. Amplitude is essentially the height of it. And we have the trough and the crest. So hopefully these things make sense to you. So the speed of light for our classes, we're going to define as 3.0 times 10 to the 8th meters per second. And so we're going to use this equation to solve some problems. So here we can see it again. C is the speed of light, 3.0 times 10 to the 8th. Wavelength is this, it's called lambda, and we're going to measure that in meters. And frequency is an s to the -1. That means essentially you're dividing by seconds, or you can see it in hertz. So here we go. We can see this. And so let's take a look at this. So we have 1.5 hertz. So C equals lambda times V. C we know is 3.0 times 10 to the 8th. And we know that equals lambda times V. And we are given V. So that's 1.5 times 10 to the 15th. Now this is just algebra. We're going to divide by 1.5 times 10 to the 15th. Divide by 1.5 times 10 to the 15th. And so that will just leave us with lambda on this side and our answer on that side. And if you do this correctly, it should come out to, maybe I can't figure out how to go on to my next slide. So it should come out to 2.0 times 10 to the -7. So punch it into your calculator. Make sure you are capable of doing that. And if you have a problem with that, by all means, come see me and we will work through that. All right, guys, that's all I have for this section. We'll kick off some more in the next video. So come see me. Thanks. Bye.